Wonderful. Thank you, guys. My name is Garrett. I'm with Agilent Technologies, and of course, we're very happy to support MetroFlow. And today, I just wanted to give a brief introduction into the detector technology that we are utilizing in the Novocyte line of flow cytometers. So, just a brief background if some of you guys aren't familiar with Agilent and flow cytometry. It really started in 2014 under the ACEA Biosciences company, where we launched the first Novocyte system. And over the course of the years, we have made consistent improvements in terms of increasing the auto sampling capabilities, the optical platforms, the number of lasers, the flexible configurations. We've introduced automation to our flow cytometers, and obviously, as you can see here, increase the number of lasers and number of channels. And so right now we are currently up to 5 lasers and 30 fluorescence channels in our systems. And this has been, I think, well received within the flow cytometry field, and we can see this by the number of publications every year. And we've pretty much, or at least our users have been doubling the amount of publications each year citing the Novocyte technology. So back to the detector. So this is, it's called a silicon photomultiplier, and it's a solid state photon level sensitive device. You can see that it's very small. That's a real picture of the detector. And so we can fit a lot of detectors into a small footprint. So these cytometers can really be on the benchtop. And the characteristics of this detector is that it has a high photon detection sensitivity, high quantum efficiency. It's very robust and has a long lifespan. And in combination with the hardware component of the detector and software, we can achieve this wide 7-log dynamic range. And this really means that we don't have to routinely adjust the detectors. We can see dim and bright signals all in the same plot. So this saves a lot of time and prevents any manual errors that are routinely seen by novice users adjusting the detectors incorrectly. And one example of this is an experiment we ran with our systems compared to some of the other instruments out on the market using 3 different beads. One is a blank bead, a dim bead, and then a bright bead. And we did this gain tracing type of analysis. So what we're seeing here is the gain on the x-axis increasing from left to right, and then we see the resolution of these 3 different particles in the plot. And so as we increase the gain, we obviously get a separation of the bright bead versus the blank bead. But what you can see here on a competitor's instrument is you can't really separate the dim bead from the blank bead. Over here on the right-hand side, you can see the Novocyte. We get good separation of the bright bead from the blank, and we are also able to resolve this dim bead from the blank. And this is just a representative plot. We see this on many channels of the Novocyte. And I just want to also point out this is not just a generic instrument. This is a pretty well-known competitor's instrument. So it's not just your general run-of-the-mill type of comparison. So not only in terms of brightness and dimness do we see the performance of this detector, we can also see good performance with small particle detection. So what I'm showing you here is we ran a series of beads anywhere from 100 nanometers in size to 1,000 nanometers. And we can see that we get good separation between the different beads, and you can see that we can even separate the 100 nanometer particles from the background or the noise. So these detectors are also useful for small particle detection, which many of you probably know that field is growing larger and larger over the course of the past few years. Another example of this, in the way that the detector can really help our types of data analysis is the wide dynamic range that we can utilize with this detector. So what I mean by that is, we're able to just see more in the same plot. On the left-hand side, what I'm showing you is actually, I'll go to the right-hand plot. We took a whole blood sample and we analyzed just using forward scatter, side scatter, the different populations of cells in the sample. So we have our small lymphocytes, we have our monocytes and granulocytes in the same population for whatever reason. And then up here at the top, which I want to emphasize, are the large eosinophils. And you can see that we're not really able to resolve these because they're really smashed up at the top of the axis. And if we wanted to, we would have to turn the gain down on the side scatter detector, and then that would be at the expense of the lymphocytes. Whereas on the left, on novocyte instruments, with that wide dynamic range, we can just see more. So we have the small lymphocytes down here at the bottom in red. We have our monocyte population, and then our granulocyte population above that, and then even at the very top, you see the large eosinophils that we're able to resolve from the other cells and see it all in the same plot. Another example of this detector sensitivity is when using cell tracking dyes for cell proliferation. So many of you guys may be familiar with this, but if some of you guys are not, we can use these, we can label these cells with dyes that covalently bind cytoplasmic proteins, and then when the cell divides, they equally partition the cytoplasmic proteins to their to the daughter cells, and you can see a successive diminishment of the fluorescent signal, indicating that there has been a cell division. And you can track this by doing routine, activation type of experiments and looking at the cells over time. So this is one example of the T cells that were activated, and then we analyzed various cell tracking dyes like CFSC, Cell Trace Violet, Viaflor 488, and you can see that when we use a software algorithm to map these peaks, you can see the successive rounds of division very easily. And you can get many rounds of division because, or you can identify many rounds of division because of the detector sensitivity, especially in those when the signal gets really dim. This is another example of comparing two different donors with PBMCs activated with plate-bound CD3 after 5 days, and you can see the type of peaks that are mapped, indicating sequential rounds of division. And this purple peak here would be like the undivided cells in this population, probably some non-T cell type. And when we analyze these in the novoexpress software, the software that comes with our instruments, you can get some really powerful metrics to compare proliferation, like proliferation index, division index, replication index, and et cetera. So, as I wrap up, I just want to quickly point out that it's not really just the detector that makes our flow cytometers stand apart. We're also able to incorporate many additional features that make your guys' life easier when running flow experiments. We can get absolute counts in every sample every time using the syringe pump. We have very fast electronics and signal processing to acquire up to 100,000 events per second. If you compare our system with some of the others in terms of fluidic stability, you can see that we can deliver reliable and consistent results. We also have a sample recovery feature, auto sampling, robotics. I can go on and on, but just want to let you know that there are more features than just the detector that make this system stand apart. So with that, I want to thank you guys for your time, and also let you know that we are hiring right now. We have an open position for an application development scientist based in sunny San Diego. So if any of you guys are interested in relocating, please take a look on the Agilent.com website on the career section. And with that, I'm happy to take any questions.
Sorry, my unmute did not take. Thank you very much, Garrett, for a great presentation. That's some really interesting and impressive proliferation data. I know that's something that I've had users struggle with in the past in my core facility. And the product information sheets always show such great data, but it's sometimes difficult to replicate. So
absolutely.
We don't have any questions that have come in at this time. We have someone with their hand raised. That's probably an error. Okay, so